Hi, welcome to chapter 11 that's on surface area and volume, and this specifically is the section 11.1 notes on space figures and cross sections. This is a pretty quick section of notes just to kind of get you familiar with some of the terminology of the chapter. And then in the next sections, we'll get more into the surface area and actual volume. So this is just one side of one page. You can do it. So first thing here is that a polyhedron is a space figure or three-dimensional figure whose surfaces are polygons. So this is a polyhedron, Hedron. Okay, so the prefix poly means many, so it can have many sides. And again, it's a 3D figure, not a two-dimensional figure. That's good to think of this at the beginning of this chapter. A two-dimensional figure is what we were just working with in chapter 10. A figure that fits just on a sheet of paper. And we were, any of those polygons, squares, triangles, trapezoids, rhombus, hexagon, all of those are a polygon, a two-dimensional figure. Now we're talking about three-dimensional figures. Adding in that extra dimension gives it that extra depth, where a 3D figure is not going to fit on a sheet of paper. We can have a picture of it on a sheet of paper, but the actual real-life object would not fit into a sheet of paper. Okay, but in this particular case, a polyhedron has all the surfaces are polygons, but it can be any type polygon. Those different faces that make up that 3D figure could be squares or rectangles or triangles or hexagons or circles. I mean, there can be all different polygons that make up these figures. So each polygon is a face of the polyhedron. Okay, so again, a face is like a side of the 3D figure. Okay, and all of those faces are going to be different shaped polygons, which again are the two-dimensional shapes that we learned in chapter 10. An edge is a segment formed by the intersection of two faces. So you can see this picture, we can see here the faces are like the different sides, where the edge is where two sides meet up. Like they're showing you, this is an edge and that's an edge. Again, it's basically where two faces meet up. So an edge is basically a line of where those two faces meet up. And then the last section here is a vertex. And a vertex is a point where three or more edges intersect. So, like this is a vertex. I can see that there's at least three lines that meet up at that point. This is a vertex. This is a vertex. This is a vertex. Think of how many are in this figure, and there are 4 more. So a total of 8. Okay. All right. Moving right along on example 1. It says, how many vertices, edges, and faces are there in the polyhedron at the right, and name them. So the vertices we just said are like the points. So point, 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 point. So there are 5. And if we name them, if we're naming a point, it's just the one letter. So and we're going to put commas in between them. H, G, D, E, and F. All right, next up are the edges. Okay, think about how many edges there are. Again, that's where two faces meet up with each other. It's a line. So we can see DE is 1. We can see EF is 1. You can see GF is 1. And we can see DG is 1. We can also see that HE is 1, going from that top vertex down to the base. We can see HF is 1. And we can see HG is 1. And we can see HD is 1. So there are a total of 8 we can see from that. And then the number of faces in this particular case, again, we can see that there are 4 triangles around this pyramid. And then there's one face at the bottom, which is like the base of the pyramid. So there are a total of 5 faces. And if we want to name those faces, then again, we just said there's 4 triangles. I can name 4 triangles. I can say triangle HGD. I can name the one in the front, DHE. The order of these letters don't matter. I can name the one on the right side, triangle HEF. And the one in the back, HGF. And then the very bottom is a 4-sided figure, a quadrilateral, and we can name it by 4 letters. So DGFE. Okay, names the bottom. All right, now if we look at the next question, it says, how many vertices, edges, and bases does this polyhedron have? So in terms of the number of faces, then, or number of vertices, those are just all the points. So if you think of what shape the base is, you can see that it's a hexagon. So a hexagon has 6 sides, so therefore it has 6 points. And the bottom base is also a hexagon, so it has 6 points. So the total number of vertices here is going to be 12. The number of edges, if you think about the bases on the top and the bottom, they each have 6 sides, so 6 and 6 is 12. But then there's also a line connecting each vertex of the 2 bases, so that makes 6 more edges, so that's a total of 18. And then the number of faces, we can see that, again, there's 1 face on top, 1 face on the bottom to represent those 2 bases, and there's 6 faces around the side that are representing, the 6 sides of the hexagon. So 6 around the sides, which is 6, plus the top and the bottom, so that makes 8 faces. And then the next thing here is talking about a cross section. So a cross section is the intersection of a solid and a plane. A cross section is a very thin slice of the solid. So I think of it as like a saw blade is cutting this 3D figure in half, or cutting it in one spot at least. And if I cut it with a saw blade and then I open up the figure to you to show you the inside and ask you what 2-dimensional shape do you see, that's what we mean by a cross section. So in this particular case, we can see that if I sliced this figure right here and opened it up and look, then a triangle is what I would see here in the middle. So I'm trying to color it in so you can see it. But this cross section would be a triangle. And then if I think of this example 3 down here, you can see that it was like a tube or a cylinder. Okay, but it depends on which way I slice it. If I slice it not the way it's showing in this picture, if I slice it kind of down the side and open it up, you'd see a circle. But because I'm slicing this a different way, and then if I opened it up to you to show you, then you would see a rectangle for this one. Okay, just kind of think about, what it would look like if you cut it in half and opened it up. Okay. So that's it for section 11.1. So not a ton to that. So I'll have you practice that a little bit. And then, like I said, we'll get into surface area in section 11.2 and 11.3. And then we'll get into volume in section 11.4 and 11.5. And then we'll do a little more with this chapter after that. All right. Let me know if you have any questions. Have a great day.